Hi everyone, welcome to EdXP. EdXP is an online platform for students to learn and assess themselves outside of the classroom. In my previous video, I taught the topic of arithmetic and geometric progression, so feel free to rewatch the video if you need to revise. In this video, I will go into some of the practice questions for arithmetic and geometric progression, also known as APGP. This will be applicable to both standard and higher level students taking the analysis and approaches subject. So let's jump right in. So this question over here actually came out last year in the May 2021 Time Zone 1 Paper 1 question 2. It's a 5-mark question, and for paper 1 we're not allowed to use a calculator. Okay, so let's break down this question. For 5 marks, consider an arithmetic sequence. So take note, arithmetic sequence, please highlight it in the exam, where U8 or term number 8 is equal to the sum of the first 8 terms and is equal to 8, the value 8. We want to find the value of the first term, U1, and the value of the common difference. So quite a straightforward question. How do we approach this? First thing, we need to understand that for arithmetic sequences, the general formula, which is also given in your formula sheet, is UN is equal to A plus N minus 1D, where A is the first term and D is the common difference. So if we look over here, the question provides us U8 is equal to 8. So I can substitute this in actually. So the first term we don't know, A plus N minus 1. N is actually 8. So we get A plus 7D is equal to 8. So this is our first equation. Okay, notice we have 2 unknowns, A and D, which means we probably need another equation to solve. Okay. Another thing to note, the sum of an arithmetic sequence, also in your formula sheet, is given by N over 2, 2A plus N minus 1D. I have derived both equations in my previous video, so feel free to rewatch them. Okay, so applying this equation, N over 2 will be 4, 2A plus N minus 1 is 7, like I mentioned earlier, D. And this is also equal to 8. And there we have both equations. We can proceed in paper 1 to quickly solve without a calculator. We can either do it by substitution or elimination. So let's quickly do this one. So from equation 1, we can see that A is equal to 8 minus 7D, okay? And from equation 2, 8A plus 28D is equal to 8. We can substitute this in. So we substitute A in, which is 8 minus 7D, plus 28D equals to 8. Expanding, we get 64, minus 56D plus 28D equals to 8. Okay, rearranging, so minus 56 plus 28, we have 28D is equal to 56. So D will be equal to 2. So the common difference is 2. So we happen to have found this first. And to find the first term, U1 or A, we can take 8 minus 7D, which is 8 minus 14, and that gives me negative 6. So let's move on to another example. So this question you see over here came out in May 2021, November paper, so time zone 0, paper 2, question 5. And we can see over here that this is a geometric progression question. The sum of the first n terms of a geometric sequence is given by this guy over here. Okay, don't have to be too daunted by this expression. This is actually a sigma notation. I usually like to express this. If I don't understand it, I try to express it out as a few terms so I understand what this is. Okay, so what we do, we sub in r equals 1 as the lower limit. So we get 2/3, the first term that comes out of this sigma notation is 2/3 times 7 over 8 power 1, okay, because r equals to 1. And to get the second term, we sum in the next integer, which is 2, all the way until n. So 2, 3, 4, 5, all the way to n. Okay, so this stops at the un term. The second term is 2/3 7/8 power 2. Okay, we can continue on, but we can see over here when I express it out like this, it is very clear that this is a geometric sequence with first term over here in green, and the common ratio is 7/8. Okay, so let's go into the question. For part A, find the first term of the sequence, u1. We can see over there that u1 is 2/3 times 7/8, which is 14/24. Okay, we can divide it and we can simplify the answer. So it's 7/12. So that's the first term. Part B, find the sum to infinity. In the IB syllabus, the sum to infinity, we learn it for the geometric sequence, okay? But take note that there are a few criteria. The first one is that n must be large, and the common ratio must be between 1 and -1, or mod r must be less than 1, okay? In order for the sum of the geometric sequence to converge to a finite value. And we know the formula is given by a/1 minus r. So I can proceed to substitute it in. The first term is 7/12 divided by 1 minus, common ratio is 7/8. Okay, so this gives me 56/12. Okay, I can divide it by 4 just to simplify. And there I have the sum to infinity. And let's move on to the last part, which is the most interesting part. Find the least value of n such that the sum to infinity minus the sum of n terms is less than 0.001. So before we start plugging in all the values in, I usually like to employ a trick here, which is to sub in my general formula for both. And you will see something quite interesting. Okay. So we subbed in the sum to infinity formula as well as the sum of n terms for a geometric sequence. So we can see actually the first two terms cancel out. Okay, and all we are left with is Rn over 1 minus r. Okay, so this really simplifies the question. And we know that the common ratio is 7/8. So we can sub that in. Okay, let's do it. So 1 minus is 1/8 at the bottom. Okay. Okay, so you can proceed to bring the 1/8 to the right. So we have 7/8 power n must be less than 0.000125. Always remember, when you're multiplying or dividing by a positive number, you do not need to flip the inequality sign. Okay, you can proceed to solve this using GDC or your calculator. So the graph will look, you can even solve it graphically. It will look something like this. Okay, we have a straight line here, 0.000125. Okay, and we have the curve. And we solve for this intersection over here. Okay, we get 67.3, 304. Okay, but always remember that n must be, let me write this down, n must be ordinal. Okay, there's no such thing as term number half or term number a quarter. It must be 1, 2, 3. It must be positive integers, also known as ordinal numbers. Therefore, n must be equal to 68. Okay, so I'll move on to the third example before we move on to some EdXP questions from the online platform. So this last example came from May 2021, time zone 2, paper 2, question 2. So GDC is allowed for this one. So let's have a look at this question. We have an arithmetic sequence. First term 60, common difference minus 2.5. Given that the kth term is 0, find the value of k. Okay, so we're talking about term number here. Just a refresher, the general term for an arithmetic sequence is un equals to a plus n minus 1d, also in your formula sheet. So we can go ahead. If we want to find the kth term, okay, that is actually equal to A plus K minus 1 D. Okay, and this will be equal to 0. Okay, we can solve this. So we have 60 minus 2.5K plus 2.5 equals to 0. And using your calculator, we can get K is equal to 25. Okay, so the 25th term is 0. That's for part A. Part B, let Sn denote the sum of the first n terms. So this will be Sn. Okay, find the maximum value of Sn. Okay, we know that the sum of an arithmetic sequence is n over 2, 2a plus n minus 1d. Okay, so let's find this first. So Sn is equal to n over 2. We're not sure what n is. We want to find that. 2a will be 120 plus n is unknown as well, but we have the common difference, which is minus 2.5. Okay, and we want the greatest value of this. We can go ahead and maybe simplify this. So we have 120 minus 2.5n plus 2.5. Okay, we can simplify this. So we have n over 2, 122.5 minus 2.5n. Okay, and this simplifies. We can use our calculator. So this will be 61.25n minus 1.25n squared. And we have a quadratic. And this is a sad phase, okay? For those who don't know what a sad phase is, if your quadratic has a negative n squared term, it would be a sad phase, and we actually can factorize this. So we can find the roots. And we can equate to 0. Okay, so you can even use your GDC to solve, but we have one root at 0 and the other root at 49. Okay, as I mentioned earlier, this is a sad phase quadratic, which means that there will be a maximum here, which is what the question is asking for. What is the maximum value? Okay, and if we halve this parabola, 49 divided by 2 is 24.5. Okay, take note that n must be ordinal. Okay, must be a positive integer, which means that our highest possible value of Sn is when n is equal to 24. Okay, so we can sub this into equation. So Sn will be equal to 24 times 61.25 minus 1.25 times. So I'm just substituting n as 24, and I get 750. Okay, a bit of a trick question here because the maximum value of Sn does not occur when n is a decimal. Has a decimal. Okay, it has to be when n is 24, an ordinal number. Okay, so now I'll move on to some of our EdXP questions that can be found on our online platform. So this question over here is a calculator question, so paper 2. A ball is dropped from a rooftop from a height of 15 meters. Each time the ball bounces, it reaches a height that is 15 over 17 of its previous bounce. Find the total distance the ball travels. Okay, so before I even begin the question, I like to visualize it. So imagine a ball that's being dropped 15 meters down. Okay, when it hits the ground, it will bounce up 15 at a fraction of 15 over 17 of its previous height. And then it comes back down the same distance. And then when it bounces up again the same multiplier, 15 over 17. Okay, so we can try to visualize this question. So the first term over here is 15 meters. Okay, and this distance over here will be 15 times 15 over 17. And notice that it happens twice, once and once here. Okay, and this distance over here will be 15 times 15 over 17 squared. Okay, and again, it repeats. when it comes down. Okay, so you should identify by now that this is actually a geometric progression. We have 15 plus, notice that the first term, 15 only happens once, so let's put 15 there. But notice that every other distance happens twice. So what I want to do is put a 2 in front because I'm multiplying. Actually a geometric sequence. Okay, so the first term will be 15 times 15 over 17 plus 15 times 15 over 17 squared plus 15 times 15 over 17 cubed all the way to infinity. Okay, in theory, the ball never stops bouncing. Okay, so we want to find the sum to infinity of this. So this will be equal to 15 plus twice of sum to infinity is given by a over 1 minus r. So the first term is 15 times 15 over 17 over 1 minus common ratio 15 over 17. Okay, so this is a calculator paper. We can plug the values in. Okay, you can do it with me. So 15 times 15 over 17 divided by 2 over 17. Okay, multiply by 2. And then we add a 15, we get 240 meters. So this is the total distance traveled by the ball. So the answer, I believe, is A. Okay, so let's move on to a final example, also from our EdXP online platform. So you can see over here that this question is GDC allowed, it's paper 2. Okay, let's go through the question. We have the second, fourth, and sixth values of a geometric progression. Okay, the general term is given by ARN minus 1. Okay, and the second term is log 312, fourth term is log 912, and the sixth term is log 8112. And we want to find the sum to infinity. Okay, so we know that the second term is log 312, and the fourth term is log 912. At this point, I want to change my base, okay, to make them all similar so that we can compare. So I can apply a change of base law, log 312 over log 39. Okay, so this change of base law. We know that the denominator is 2, so this will be half log 312. Okay. Going from the second term to the fourth term, we're actually multiplying by common ratio twice. So r squared will be equal to fourth term divided by second term. Okay, we can see that the two terms cancel out here, which means that r is plus minus 1 over square root 2. So looking at the answers over here in the MCQ, we can see they're all positive. So we can probably say that r is the positive common ratio because there are no negative numbers in the answer. Okay, so to find the sum to infinity, it's a over 1 minus r. We already have common ratio. To find a, u1, right? We can take the second term and we divide it by the common ratio. Okay, fundamental. So we have log 312 divided by common ratio 1 over root 2, which gives me root 2 log 312. That is my first term, or A. Okay, and finally, to find the sum to infinity, we can take a over 1 minus r, so log root 2 log 312 divided by 1 minus common ratio is 1 over root 2. Okay, if you want to input this in your calculator, you can. Okay, so it's root 2 over 1 minus 1 over root 2. You can even change the base here, so you get log or ln 12 over log 3. Okay, so let's plug this into our calculator. You can pause the video if you need to try. Okay, so we have root 2 divided by 1 minus divided by root 2. Okay, from the GDC, the answer is 10.9. Let's keep it to 3 significant figures. So I believe the answer is B.